This is a nice puzzle. Your teacher gives you a treasure chest with a 3-digit lock. If you enter the correct code, you get the reward inside. But instead of telling you the code directly, your teacher gives you 2 sequences. The first sequence is the Fibonacci sequence, and we call it AN. The first 2 terms are both 1, so we have A1 equals 1, and A2 equals 1. After that, every new term is the sum of the previous 2 terms. In other words, AN equals AN-1 plus AN-2. So the sequence begins like this: 1 1 2 3 5 8, and so on. The second sequence is a geometric sequence, and we call it BN. Its first term is 169, also equals to 13 square, and its common ratio is 13. That means the general form of Bn equals 13 to the power of n plus 1. Now your teacher tells you to consider the sum of A1 over B1, plus A2 over B2, plus A3 over B3, and so on. If you keep adding these terms forever, the series approaches a limit, and the reciprocal of this limit is exactly the password to the chest. So the question is, how can you calculate the limit and find the password? Please think carefully and use your advanced brain. To solve the puzzle, we first need to find the value of the infinite sum. Let's call that sum as S. Then we can rewrite S equals 1 times 1 over 13 square, plus 1 times 1 over 13 cubed, plus 2 times 1 over 13 to the 4th power, and so on. Next, we factor out 1 over 13, then gives us S equals 1 over 13 times 1 over 13, plus 1 times 1 over 13 square, plus 2 times 1 over 13 cubed, and so on. Then, we let f of x equal x, plus x squared, plus 2x cubed, plus 3x to the 4th, plus 5x to the 5th, plus 8x to the 6th, and so on, to the infinity. Therefore, S equals 1 over 13 times f of 1 over 13. Since 1 over 13 is less than 1, the infinity sum of f of 1 over 13 is convergence. When we get the value of f of 1 over 13, we can calculate S, and then the password, which equals 1 over S. Now let's find a closed form expression for f of x. To do that, first multiply the whole series by x. Next, multiply the original series by x squared. Now comes the trick. When we subtract both of these new expressions from the original f of x, all the remaining coefficients cancel out. Why does this happen? Because the x with the same power has the coefficient in Fibonacci sequence and satisfy the rule, an equals an-1 plus an-2. That means that after the first term, all the remaining coefficients cancel out. Only an x from the first term remains on the right-hand side. So we are left with f of x minus x times f of x minus x squared times f of x, all equals to x. Then we simplify it and get f of x equals x over 1 minus x squared. Now, here is the final part. We need to go back to the password we actually want. We substitute x equals 1 over 13 into the formula for f of x, and that simplifies to 13 over 155. Now substitute this result back into our expression for s, which equals 1 over 13 times f of 1 over 13. Then, we get s equals 1 over 155. Finally, the problem says that the password is the reciprocal of s, which is 1 over s. Therefore, we get our final password of the treasure chest, 155. And this is the key to the treasure inside. If you enjoy puzzles like this, and want more problems that challenge your math skills, Please subscribe to Advanced Brain and keep thinking smarter.